Okay, so let's have a look at the second video that looks at the different approaches that can be used. So firstly, in the last video, we saw contextualized learning. And remember, that is when learners learn in context with authentic activities. And CAPS does provide for that type of approach. You can use contextualized learning because it uses the applications of science in their everyday life. We also looked at the history and philosophy of science approach, and there the approach is pretty much a history of science approach, taking the historical experimentation and the scientific discoveries history. And yes, the CAPS document does allow for that too. Then the science, technology, and society approach that equips learners to deal with the skills and values they need to participate in society and make informed decisions. And by carefully selecting the content, we can look at the contribution of science to societal development, using scientific knowledge responsibly, and the practical and ethical consequences of decisions based in science. So now, the fourth approach we're going to look at is the integrating of Indigenous Knowledge Systems approach. Now, students bring different worldviews to the classroom, and teachers are confronted with learners whose worldviews might conflict with scientific explanations. So, to include some aspect of Indigenous knowledge in the formal science curriculum will help students bridge these two worlds. This cross-cultural approach to teaching science for non-Western learners is suggested because of cultural differences between learners and school science. And success in school science will depend on how efficiently these students are able, or these learners can move between their life and world culture and the culture of school science. Inclusion of Indigenous knowledge could make many curricula relevant to many students. Now, the traditional methods of preserving food, for example, to prevent spoilage from microorganisms, traditional methods for brewing beer compared to traditional Western methods for making beer, traditional methods for insulating homes, traditional cures for ailments of the digestive system, and then there's also the processing or the, should I say, the smelting of steel, which was first what was done in Britain, was done centuries before by African cultures. So does the curriculum allow this? Well, there's a specific section on Indigenous knowledge systems and science being only one way of knowing, and that we should try and integrate Indigenous knowledge systems to help students understand different cultural contexts in which the Indigenous knowledge system. Now, the fifth approach is inquiry-based learning. Inquiry-based learning allows learners to develop key scientific ideas through learning how to investigate and build their knowledge and understanding of the world by using the skills employed by scientists. These skills include raising questions, collecting data, reasoning and reviewing evidence, argumentation, and so on, discussing results, presenting results. And when we look at the science process skills, you will see how closely related these are. Now, students need to work collaboratively also to plan and conduct and report investigations. Now, the whole conception of inquiry is more than just practical work. It encompasses more than practical work. And observing and handling materials. It's the process of doing science. So here they use science knowledge as theory to investigate phenomena that students are interested in. So students do science, and this is through the process of science, the inquiry-based learning experiences. They investigate and discover science. It stimulates their interest in science, and it improves their understanding of concepts. It leads to an understanding of the nature of scientific knowledge. It facilitates collaboration between learners, and it helps develop the experimental skills. And then having students actively think and participate in the investigation process increases their science conceptual learning. Is there a place in the curriculum? Well, it talks about science having certain methods of investigation that are used, carrying out experiments and testing hypotheses, and that through the selection of content, students can learn about the curiosity of the natural world. Then, of course, there's specific aim 1, the doing science, where they have to complete investigations, plan simple investigations, solve problems, and so on. And the the list of scientific process skills: accessing information, observing, comparing, measuring, sorting and classifying, identifying problems and issues, raising questions, predicting and hypothesizing, planning, doing investigations, recording information, interpreting that information, and communicating their findings. Then number 15 deals specifically with the scientific process and the fact that problems must be identified, you form a hypothesis, you design, you observe, you make inferences. So yes, there's definitely room for inquiry-based learning. There are some readings again. And here is the one-pager with choose one of these 5 approaches and write about how these approaches can develop scientific literacy.